Another one. Yeah, I think. All right. Chair out of the way. All right. We'll definitely get through 4.3 today, and with any luck, start 4.4. But just to finish up with this one is related to or similar to one you might find in your 4.2 homework. I think maybe it's one of the last ones. In this section, you're asked to plot points and then graph those points, or graph the line by finding points to put on your graph. And we've had our equations in a couple different forms regularly, and you know, kind of if it's this way, try putting numbers in here, and if it looks like that, then you know, let's try it a different way. Well, here's one that's not in either of those forms. One of those forms had plain y equals everything else, and the other one had x's and y's on one side. So what do you do with this? Well, probably the best thing to do, it means a little more work, is move it around and put it into one of those forms. And then use the technique that we've been practicing when it's in that shape. So one of our forms just had the x's and y's on one side. So if I'm looking at this one, it's like, okay, x is over here and everything else over there. How about if I just subtract the 12y? I could move it over. And I'm going to purposely kind of put it in that x and then y order. So if I subtract the 12y, cat or pen, if I subtract the 12y from both sides, I get to that. It's not a big deal for us, but the convention for an equation that's in this shape is to usually make that leading number positive. You can imagine if I multiply everything by -1, it would change all the signs on both sides. It's not a big deal for us, but it's just kind of the convention for this form. I'm not going to worry about that. When it was in this shape, I would usually say, well, it works really well to use the zeros, especially if these two numbers divide evenly into that one. Well, these are both bigger than that one, and so that's not going to work. If I put in zeros, I'm going to get fractions, right, for both of those intercept values if I put in zeros. So I'm going to suggest let's keep going and let's make it into that y equals all that other stuff shape. Okay, so that means I've got the y over here now, or maybe I could have done it up there and just moved the 4, right? But I'm going to move the x's. So you can work with it. You know, you can just deal with the fractions and, you know, get what you get, and that's okay. But if I do this, there I've got now all the y's on one side and the other stuff on the other side. And the form, this form usually had just one y. So I'm going to divide now by this -12. The text does go through this process. Oh, that's too bad. This will be a fraction. Go through this process of rearranging as a good choice for this kind. But now what do I get? Y equals -8/12 is going to be 2/3. Dividing by 4s in my head anyway. And I guess -1/3. Well, now it's in that.
Would it make a difference if you were to have moved the 4 originally? Would that have changed like the signs of it being a negative number or anything?
No, that's, I would have added the 4 and then I divide by +12 and you know, the signs would have been the same. No, I just kind of went a long way around, all right? Now it's in this shape and I can say, oh, if I want to get some nice numbers, now it's still going to end up with some sort of fraction because I've got this minus of fraction. But now I could decide to deal with the zeros here, or maybe I could pick some numbers that work well with the 3. So I get for making up an example here, right? Still going to have some fractions. Pick some numbers that work well with that 3 as a denominator. Pick some multiples of 3. So, you know, I'll keep going. If I use 3, 0, how about just 6? All positives. I'm going to give myself some room. Okay, I'm going to erase where I started. Yeah. All right, if I put the 3 in there, right? So I put a 3 in. Call it 3 over 1, and then what is it, minus another third? Oh, well. 3's go away. Minus 2, negative 2 minus a 1/3. How many, if I'm going to combine those, I'll need a common denominator. Let's make this 3, make it 3's. How many 3's in 2, right? 3 over 3 would give me negative 6/3 minus another negative 7/3. So still kind of messy, right? But it's one way, maybe it's better. Maybe it's a better approach to finding points than just trying to work with what you had to start with. But really, in the form that I presented to start with, you could still just pick any old number and plug it in for X and then do all that work to figure out what the Y is, especially if it's going to be a fraction anyway. Or pick some number for Y and do all that work to see what your resulting X value is. And it just, looks like there's the possibility you're going to get fraction values. If I do the same thing with the 0, negative 2/3 times 0 minus 1/3, well, that's just going to be negative 1/3, right? 0 times that fraction is 0, negative 1/3. And so I'll do last one here. I'll put the 6 in, right? Negative 2/3 times 6 over 1 minus 1/3. Now that cancels some 3's. That's going to be negative 4 minus 1/3. And again, common denominator, 12. Negative 12/3. That is common denominator 3. 4 is 12/3. Negative 13/3. Oh, what fun. Move that down a little bit. Now, how am I doing? Just checking my, so, it's just you gotta be careful. Work with the numbers. You can choose any number, just work with what you have. If it turns into fractions, you gotta get your common denominators to add or subtract. Now I've got 3 points. Maybe we'll use this now as a chance to continue with our discussion. How do we graph the fractions? Several of you just didn't like that. How do I, well, the point is you have to estimate that position on your number, on your grid, on your number line. So if those are okay, I'm going to keep going. So I kind of change and now try to graph those points. But I'm going to erase this. All right. Just showing one way, I suppose you could put it, of dealing with those when they don't look like they're in the usual shape. All right, I got all those numbers over here. I'm gonna try to graph over here. Now my X values are nice integer values. I'll be on, one of those solid numbers, you might say. This says when X is a 3, my Y is negative 7/3. Now, so I get from making that statement early in the class, we hardly ever use any mixed numbers. But to kind of put that on a graph, I need to think of that either as a decimal value. I could do 7 divided by 3 in my calculator. You'll get a decimal approximation, 0.33333. Or maybe how many 3's? How do you turn that into a mixed number, right? How many 3's are in that 7? Well, there's 2 of them. Gets me to 6, and there's 1/3 left. Or 2 times 3 is 6, and 1 more gets me to 7, going back the other direction, right? Turning it into an improper fraction. So there's a mixed number equivalent for that improper fraction. Right? Putting that on the graph. Okay, I'm at 3. All right, so that point's got to be somewhere at this X value, and the Y is negative 2 and 1/3. 2 down and another 1/3 down, right? 2 down and a 1/3 down. Now just on the Y-axis, I'm over here, right? 2 down and a 1/3 down. So there's the Y value. I haven't really done the intersecting lines idea, but count over on your X-axis, it's got to be on that line, and count down your Y-axis, it's got to be on that line. So there, I was just I really am eyeballing it, estimating it. I mentioned to somebody who posted yesterday that really this is sort of the limitation of the graphing method. What if we were trying to look at the graph and trying to figure out what's a solution to that equation? What's that point? Oh, is that a quarter? Is that a third? Is that a half? You know, that graphing is not ideal for actually reading a graph to find a solution, unless you get really lucky and it's right where the lines cross. So there's one point. I'll finish up these other two. 0 for x, negative 1/3. Well, all right, that is right there on that number line. Where's 1/3 on the y-axis? And 6 for x, now 13 thirds negative, right? Well, 13 divided by 3 is 4, gets me to 12. And there's one more third left over. 12 and one more. So negative 4 and 1/3. I'm over at 6. 1, 2, 3, 4, 5, 6. And negative 4 and 1/3 more. 1, 2, 3, 4 and 1/3 more. Hey, not bad, right? So I might say, I'm sorry, but if you run into a fraction, you've got to try to get it on the graph. You really just kind of have to, come up with your version. That, this would have been negative 2.33 repeating and negative 4.3 repeating if I come up with a decimal approximation. That's okay, I think, for trying to get a number to work with when you're just trying to figure out what number to use to put that on the graph. But do your best. And another point I tried to make is you're not going to run into a lot of fraction kind of answers like that. Occasionally, and I guess we do need to know how to get it on a graph. Okay, I wanted to start with that. We kind of covered two things with that. Maybe rearranging an equation, put it into one of those familiar shapes to try to make selecting numbers for plotting points to make that a little easier. And then here, trying to practice graphing some fraction values. All right. 4.3. I claim we've been doing this. Graph with intercepts. Can you read that? Yep, okay. Using the intercepts to graph just means you're plugging in a 0 for x and see what I get for y. Plug in a 0 for y and see what I get for x. And then we're going to find points that are the intercepts. They're on the axes. Once I've got those 2 points, I can graph, right? Oh, anytime it's on the x-axis, right? Got some number a. The y value is 0. That's the point I'm making, right? If I've got some number on my y-axis, hope I didn't say that backwards a minute ago. If I'm on my y-axis, the x value is 0, right? Just some number. So one of your values, coordinate values, is always the 0. All right? So I've got an equation. Here's one of those with that basic shape that I've suggested works really well by plugging in the zeros. Graph this line by finding the intercepts. Oh, well, that just means I'm going to do this. Plug in a 0 for x and see what I get, and then plug in a 0 for y and see what I get. And those would be 2 points to put on the graph, and they should be on the axes, and I'll draw the line. If x is a 0, here I kind of do my cover-up thing, right? Oh, I won't shortchange you. 3 times 0, though, is 0. 2y equals 6 means y must be 3. 0, 3. Plug in 0 for y. 3x is 6. So divide by 3, I get x is 2. And so there are the intercept values. When x is 0, y is up at 3. And when y is 0, or x is 2, y is 0. And I could then connect those dots and get my line. I found those intercepts. Oh, let's get Maddie in here, somebody else. Good. All right. And let's try one like, now here's one in the other shape, right? Well, what if I'm asked to graph using the intercepts? By the end of our chapter, if you're asked to graph, you'll be given the choice to choose your favorite method to graph, right? Just plot some points, get them on there, or use this specific intercept method. By the time we get to 4.5, we're going to hopefully recognize some important information in this shape in particular that allow us not even to worry about plotting specific points, but be able to kind of just use the numbers that we see. We'll do something else. But if I want to use the intercepts, that still just means I'm putting in the zeros. Now, this one I'll have to do a little more rearranging because it's not in that other shape. If x is a 0, well, that one's not too bad, really. Y equals 0 plus 4, y equals 4. That's easy. All right, there's one of the intercepts, 0, 4. Now, if y is a 0, yeah, I got to solve for x. Got to move things around, right? Subtract the 4. Divide by the 2. X is negative 2. So when x is negative 2, then I have a y value of 0. So the process of graphing using the intercepts is just that. Plug in 0 for x and see what you get for y. Plug in 0 for y and see what you get for x.
I have a quick question.
Yeah.
Yesterday you mentioned we should probably put in like a third x or something just to make sure that it's correct. Do you still want us to?
If you want to find a third point, you know, make sure that, it's not up here.
Okay, so the third point is just to like check work almost.
Yes. Only takes really 2 correct points to define that line.
Okay, thank you.
Yep. Now let's see. I'm going to make up one where I'm going to get a fraction. Okay. Sometimes, if you're using the intercept method, your intercept could be a fraction value. That still means they're asking you to put in the 0 and see what happens. If x is a 0, divide by the 5, I get 6/5. That ordered pair of 0, slow down, Steve, make it neat. 6/5. That would be a real, how do you estimate a fifth? That's pretty small. If I have a 0 for a y, right, that one's not too bad. Divide by 2 and x is a 3. So my x-intercept is nice numbers, 1, 2, 3, 0. My y-intercept, though, is up at 6/5. Here again, an improper fraction, more than 1, less than 2, right? 1 and 1/5. And 6/5, so I'll say that's kind of like right about there. And being sloppy there, but found my 2 intercept values, and one of them happened to be a fraction. But that's what you're asked to do. Just find those intercepts, do your best to graph that. I bet Mom's gonna kind of grab the right spot if you're close. I'm just guessing there. All right. And I guess what that comes down to is if you get fractions occasionally, you just kind of have to work with them, do your best with them. This does kind of set us up a little bit to talk about what's the big deal with the intercepts, right? The number here or the number here. So I guess I'm kind of working up to word problems eventually, right? But the context, you know, what do those intercepts mean, all right? So how about, I'm just going to sketch a graph shape and then ask a question about it. I don't know. I think I need this part of the graph. Okay, I'm going to say, here's a graph, right? That shape, and it describes, say, my distance from my destination based on time. Describes my distance from a given destination and based on how long I've been traveling. So the question is, what does this intercept value mean? If that's the story, what does that intercept value represent? My distance from my destination based on time. You know, starting at time 0, that's the first thing I recognize. I mean, if this is time, if I'm here, this is at time 0. What does that stand for? Time 0. I'm traveling. How long have I been traveling? I haven't traveled any time yet. At time 0, this value represents how far away I am, my starting distance, right? At time 0, my starting distance was this number, whatever it is. What does this intercept value then represent? Here's my distance, right? This vertical is how far from home am I, whatever. How far from home am I? Well, this y value is 0. I got home. What's the other important number in that ordered pair though? What is it telling me? How long it took me to get there, right? This is something like t to get home. That long to get home. Okay? This one over here is saying I started at that distance from home. Right? So interpreting the intercepts. That's what we're going to have to do more and more of it. I've got this line. What does it mean? Right? How about it? All right, with any luck, how about this one? And again, notice I'm just kind of using the first quadrant because I'm dealing kind of with positive physical dimensions or things like that. I'm not really going negative right now. So if I really just chop it off right there, it's implying that the x-intercept wouldn't make sense in the context of the story I'm about to make up. Yes, mathematically, this equation keeps going and that line would keep going, but this number doesn't make sense for the problem in the real world. But let's say this, with any luck, this graph represents the value of a certain investment over time. The value of some money that I saved or put into an investment. Hopefully it's growing over time, all right? What does that intercept value mean then? Again, I'm using time. That's kind of a nice context for this discussion. If I'm here, my time value is 0. That's when I started. What's that number stand for then for this investment? Any brave souls out there? I started with that much. That was the starting amount of my investment, was what this intercept represents. And then with any luck, like I say, it went uphill from there. It gained value over time. Another one kind of like the first one. This is the amount I still owe on my mortgage. I took out a mortgage for my home. This graph describes how much I still owe based on time. What does that intercept mean? All right, somebody, come on. This is my mortgage. How much do I owe? What would that value represent in this story? I took out a mortgage. Someday I hope that works for everybody if that's what you want, I guess. I took out a mortgage and I pay a little bit off over time, right? Long time. I think I got 3 years left on mine. Starting at time 0, right? The time value is 0 if I'm here, right? That's how much mortgage I took out, right? That was the value of this loan. That's how much I borrowed. It was this amount. And over time, how much I still owed went down. What's this intercept telling me? The amount I owed now has finally gotten down to 0, but it took me this much time to get there. How long to get to 0? How long to not owe anymore?
So I have a question. I'm just kind of confused on like how to take notes about what you just said. So
Yeah.
how can you put that in just like a simpler
Yeah.
way? I'm just like a bit confused, but I'm like so close to getting it.
Time. Time to finish. When you're on the y-axis for the story, whatever the context of your word problem is, that's usually where the story begins, the starting value in the problem. I started with this situation, this number of things or amount of money, and then the more I did something else, it changed. It either goes up or it goes down. If it goes up, you're not going to get an intercept, right? But if it's going down and down and down, after so many changes, it finally gets down to 0. And whatever this axis is, number of items or amount of time, that's, time to get to 0. How long did it take, or number of items it took, number of changes it took you to get down to 0. I know, hard to.
Thank you for explaining that.
I try. And let's see, maybe I had one more. Oh yeah, like this one. I'm gonna leave those word problems. Often it's money, right? Sometimes it's not. How about this one? Describes manufacturing costs to produce, this n number of items. All right, the more I make, of course, the more I have to spend to make them. So.
Okay, so in this case, the starting point would be like how much money you're spending on whatever it is to begin with. And then it explains like how much money you're spending to keep like the business going, kind of.
Yeah, or, this is going to actually we'll sort of build on this idea in the next section. How steep this line is kind of tells me, how much does it cost to make each item,
Okay, thank you. That makes sense.
Yeah, but this is, even if I don't make any, my business has overhead or starting expenses or something like that. I haven't made anything yet, but I still need to have overhead or something like, business term, right? Just to run a business or pay for my license or anything, I had to start here. I haven't even made anything yet, and I already spent $2,000. Now I'm going to start spending money for each additional thing I make. So, starting point, just to get started, I spent this much. So it's kind of the trying to interpret what the intercepts mean. It does remind me, I looked through the mom questions, kind of try to do that every time, but be careful to read the units, right, on the axes. They're not all ones, in particular in the applications, in the word problems. And I noticed like there was one of them, it's probably similar, everybody's numbers are a little different, but they went something like this, 2, 4, 6, and then this one was 12, 24, 36 for every other one. And then you were supposed to, oh, maybe I was looking at 4.4, but just be careful that you look at the units carefully. If I'm talking about this point here, there's not a number on it. Oh, but if that's a 2, I got to figure out that's 1. Or this one, that must be the 5 in between. That's kind of all I'm getting at. Just notice these units aren't the same size as those units. So let's look carefully at the graphs, okay? All right. Well, all right, hold on to your seats. Here we go. Take a sip here. Wow. Whoops. Laughing while I'm drinking. All right. Well, how steep is that line? Concept we call slope. All right. Already we've sort of talked, let's say, qualitatively versus quantitatively without numbers, right? Qualitatively, just recognizing that's going uphill. We say this has a positive slope, right? Between, we're always kind of evaluate that going left to right, looking left to right, ever increasing. This is going uphill. It has a positive slope. I sort of started addressing that number in a certain equation. That number will be positive. And similarly, that one's negative. All right? And that means something about the values, the numbers in our equation. And slope is a rate of change. How much does this value change per that amount of change? Like miles per hour is a rate of change, all right? How many miles do I travel based on how long I traveled? Or cost per ounce. How much does it cost for this many items? The more I buy, the more it goes up. The thing about linear equations that's unique is that rate of change, that slope, is the same, all right? And it is a ratio. That's what we're going to come up with. It's a ratio of two different numbers. So, if I figure out if I go that far, I go up that amount. This is going to basically be a general definition of our slope. But if I go that same distance, I'm going to go up the same amount. Same distance, same amount. That rate of change is consistent. It's what makes it a line and not something that, oh my gosh, I'm getting faster, 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 faster. The rate of change is ever increasing in that curve I drew. That's the problem with the virus, right? So the rate of change for a linear equation is constant. It's always the same amount of change for the units that you're traveling. Okay, so how do we describe it. Drop my rack here. So for a couple things we want to recognize. First of all, I created these as ratios that are rates, right? One kind of unit divided by the other. And those units directly relate to the units on my graph. Like this would be miles per hour. What distance have I traveled based on how long I've traveled? My rate, my speed, is a comparison of the number of miles per hour. Or the same could apply to, this could be the cost based on quantity. All right, cost per ounce. Cost, notice the top number is my Y number. The bottom concept is my X value. That's going to be important when interpreting the slope. What are the units of that slope? It's the comparison of the units on your graph. Okay. Yeah, exactly. We reserve the letter M in our equations for the slope value. All right, in our equations, that if I'm writing it like a formula, right, generically like a formula without any numbers, the letter M is that rate of change value, that slope value. Okay, and we've already seen, just sort of given you a looking ahead. See that equation shape? We've seen a few times. Already talked about that number that's multiplying the X. That's how steep our line is. Is it positive going up or is it negative going down? Is it a big number really steep? Is it a fraction kind of shallow? All right, that number there in that shape of the equation is the slope value. We have to be able to come up with the value now, the numerical value. We have a couple sort of like helper phrases. First, rise over run is a common helping phrase, right? It's a comparison, right? Still rate of change of these two different values on our graph. Your rise, how much up and down did I go, up or down, right? For a certain amount of horizontal travel, that's the run. Rise over run. The idea here is to help people remember it's the Y values on top and it's the X values on the bottom. Okay, rise over run. Okay. Can I erase?
Can I just have one more second, please?
Yes, good. Thank you. Thank you very much. All right, I'm gonna, maybe you can just leave that there. Here's a line, and I have identified, recognized two good points, places where the lines are actually crossed and it's not a fraction. Okay, I found two good points to work with. And I want to figure out what that slope or rate of change is. If I've got a graph to look at, I just want to count the squares and watch the units, count the squares, right? From some starting point, and it really doesn't matter which, and I'll try to convince you of that eventually. From some starting point, I want to figure out how much did it go up for the amount, how much did it change horizontally, vertically, compared to the amount it changed horizontally. So just counting squares. I'll start with the rise. From this point, I went 1, 2, I went up 2. I changed 2 units from here, right? From here up to here, I changed 2 units. I went up horizontally from here over to there. I went 1, 2, 3, 4. I changed 4 units. There's my slope value. And I would simplify that fraction to 1/2. This is telling me for every 2 units I go in this direction, 1, 2, I go 1 unit in that direction. 1, 2, up 1. 1, 2, up 1. 1, 2, up 1. That's the slope of that line. And notice both of those were positive numbers. From this point, I went +4 and +2. Oh, let me be a little more interesting here. I'm even going to go way down here. That's supposed to look like it's at the -1, and this is up here at 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4. Okay. Same thing, right? What's the change in y? I'm going to do this one both ways just to show you how it works, that it works out either way. If I choose this as my starting point, my y value, my rise, is actually a negative rise. That's important. It went down, right? So I went 1, 2, 3, 4, 5 to get down to that -1. I went down 5. From here over to there, I went 1, 2, 3, 4. I went +4. So this slope, I would probably put that negative out. It's now a negative fraction, right? Negative number. My slope is negative. That line through those 2 points should look like it's going downhill. I have a negative slope. I'm just carefully counting the difference in the squares, counting the squares. Make sure you get your y value on top and your x value change on the bottom. Now, if I had started from the other point, right? What if I, well, I like this one better. If I count from here to get up to there, right? I went 1, 2, 3, 4, 5. I went up 5. I went up 5. But from here, I went back -4. So see how the signs still just work out? One's still plus and one's still minus. If I had done it on this one, it would have been, you know, -4 and -2. Minus over minus would still have been a positive value. Negative divided by negative. All right. So this is implying at this point you have a graph that you can look at, right? You have a graph that you can look at. And again, you're looking at a graph on mom and there maybe are giving you very nice specific points. You want to be careful to look for, oh, I know that one crosses right there, you know, 2 lines right there. Oh, where's the next good spot? Oh, it's like way out here that those lines cross. Avoid fractions. That's all I'm saying, avoid the fractions. So now I found 2 good points on my graph. Now I'm just going to count the squares. Make sure you are accounting for the units. That's the one I was getting at about the different units a little bit ago. I was talking about, you know, the 2s and the 4s and the 12, 20, anyway, yeah, 12, 24, 36. And I remember people looking at that graph and saying, oh, over 1, up 1, over 1, up 1, you know, 1 over 1. Ah, but these are, you know, that's 1 unit, but this is 6, right? I went over 1, but up 6 because of the units there. Just got to watch out for your units. A side conversation there, sorry. All right, what's my slope here? Still back to 1s, 1s and 1s. All right, so I'm gonna say that one. I should have drawn a little better, but I'm saying it starts from a 1 and goes over to whatever this is over here. So You can count the x's first if you want. I went from here all the way over to here, right? Notice I'm kind of drawing a little right triangle in there. How many units here? I went 1, 2, 3, 4, 5, 6, 7. I'm going to call that 7 for my run, right? My horizontal change was 7 units. How much is this change? I went 1, 2, 3, call it 3. There's my slope, a slope of 3/7. Who knows what the story is for this problem, but I'm just trying to calculate, come up with this number, right? Well, the next step is to say, well, what if we don't have a graph? What if we just have points to work with? And I know the coordinates of these 2 points. How can I figure out the slope? Well, it's just going to be a subtraction problem. Calculate the difference. Calculate the difference between the x's and the x's and the y's and the y's. But we're about out of time, and rather than jump into that today, I think we'll just pick up with that tomorrow, and we'll finish up our slope discussion, and maybe hopefully have time to start 4.5 also tomorrow. Okay, so I'll stop that for now. If you're interested in trying to get started, I think this will get you through the first few problems in 4.4. 4.4 is one of the longer homework sections I've noticed, 18 problems, and there's like several different sort of sections to it, and we've kind of got through the first section of, say, maybe like 3 sections in 4.4. So you could get some of them done if you're trying. All right. So any issues or questions before I leave you?
I have a quick random question.
A quick what?
I have a quick random question.
Random, all right.
The M obviously is like the slope, right?
Yes.
So how do you know why they picked an M?
Pardon?
Do you know why they picked an M?
Oh, I don't specifically. A lot of the format conventions, here's my stock answer. A lot of them, these ideas were developed in Europe hundreds of years ago. Maybe there's a French or German word.
Okay. Yeah, I've been wondering that since 7th grade, so.
maybe that relates to, measure of something,
Okay. Cool,
something.
thanks.
That's my, I don't really know, but there's a guess. Okay. Yeah, I usually say something like that because, no, or maybe it's because we don't use M for hardly anything else. So let's use M. Anybody else? Well, all right. You folks have a good day. Enjoy this weather. Pardon? Somebody else? All right. Well, have a good day then. See you later. See you tomorrow.
Thank you.
Mm.